Hello, now we're back again to continue the story. I'm now going to say a few words about this topic here, and then we'll get going with the problem proper. Anyway, despite all its impressive functionality, computer algebra systems such as Mathematica is basically a programming language, so that users should get more out of using one by adhering to some of the basic principles of software design, such as modularity, reuse, and interoperability. So in my 15 years of experience of investigating how to best use a computer algebra system in mathematics education, I've attempted to derive a syntax for mathematical knowledge which is consistent with these principles. Anyway, as I've always found it easiest to extract general principles by studying examples, I will describe this syntax in connection with a simple, well-known example, which is the algebraic geometry of ellipses. And finally, I'll show how to reuse some of the tools and construct some others to solve the problem of drawing tangent lines to an ellipse. So let's get on with the first meaning of equality, which is the naming of mathematical objects. So, in the context of our problem. So, most students will be familiar with the parametric representation of the coordinates of a point on an ellipse in terms of this vector-valued function r of t, which is equal to this, where a and b are the semi-axes of the ellipse, and for any value of t that I put in, any real value of course, this will give values for the coordinates x and y of a point on the ellipse. So anyway, let's now start using Mathematica in this context. So we're going to define we're going to define the vector-valued function like so, and execute it, and we're going to call it rvec. So that defines the vector-valued function as a mathematical object. And we're going to define the coordinates of the vector-valued function as using the name coords. In these two cases, the sign or the equality sign is used to establish an identity between the name on the left, which could be rvec or coords, and whatever object appears on the right. And we can see this most easily by executing the command rvec and see that it is identical, or the name rvec is associated with this mathematical object here. We can perform routine mathematical operations such as differentiation with respect to the parameter t on this object using this. So the Mathematica function is d. We apply it to our vector valued function whose name is rvac, do it with respect to the parameter t, and if I execute that, then that is a vector in the direction of the tangent to the ellipse. The names given to mathematical objects should be illustrative and easy to spell. And since all built-in Mathematica functions begin with uppercase letters, this should be avoided in the names of our objects. The single Roman and Greek letters are reserved for the names of parameters and variables and are never used as names, singly as names. I've always also found it useful to reserve names like coords for the lists of variables, because the first coordinate can be referenced using this, which produces the first variable in our vector of coordinates independently of the actual name of the variables. This means we can build tools which work independently of the actual names of variables. Names of objects such as vectors and matrices are given the suffixes vec or mat, and the names of objects which assign values to variables and parameters end in set or sol, the latter being the case when they emerge as solutions of equations. So let's hold a pause.